Hello and welcome everybody. This is the tutorial series of using Scratch with the Raspberry PI's GPIO pins, okay? This is the Raspberry Pi 4GB model with the Labis kit on it, which we'll get into more so later. In this series you'll be learning go from blinking an LED, which is in this tutorial video, to creating small little robots and stuff just with Scratch. Scratch is great if you just want to learn a simple programming language that if you don't want to do much programming in robotics and more of the fun stuff and just want some simple programs run, Scratch is great. And it works well with the GPIO pins on that Raspberry Pi. This is like the Python series, only with Scratch instead, because Scratch is simpler. And we'll be using the Raspberry Pi 4 with the Labis kit. Any Raspberry Pi with 40 GPIO pins and Raspbian full installed will work. The Labis kit I'll leave a link to in the description in case you want to get one if you don't already have a Raspberry Pi. The Labis kit comes with a fan, a case, heat sinks, a power cord with a switch, 2 HDMI cables, and all for a low cost of just $100, so it's not bad. So I'll leave a link to the kit if you don't already have a Raspberry Pi. If you don't have any supplies for any of this robotics stuff or GPIO pin stuff, like the pin connectors and LEDs and all kinds of tinker stuff that we're going to be working with through the series, I'll leave a link to the kit we're using throughout this series in the description so you can follow along. We'll also be using the same kit with the Python series, so you'll be able to follow both series using that kit in your Raspberry Pi. So, looking at it, what you'll need is you'll need to open up your Scratch. You'll need to open up your Scratch 3, not just Scratch, it has to be Scratch 3. This also works with Scratch 2, but we're using Scratch 3 in this tutorial series. And you will need to get one male to female connector out of your kit, 2 of them actually, one brighter one and one darker one for positive and negative. And you'll need one male to male. If you do not have a female to male, which most kids don't, I bought these separately, you want to connect your female to male. So you'll have a cord like this, and then another one that's female to female. And you'll be able to connect them and get a female to male cord out of it. So if you don't have one in your kit, just connect a female to a male to male cable. You'll need a breadboard. This is a smaller breadboard I'm using. It will be in your kit if you got the same kit. We're going to talk about breadboards here in a minute. And you'll also need a resistor between 200 and 1K ohms for your LED. And you'll also need an LED. We're going to be making an LED blink today using the Scratch. Keep in mind, I just wanted to let you guys know we won't be going too far into PWM in this series. I don't think if we do, it'll be later on because PWM is harder to use with Scratch. You're better off using Python. So if you're really needing PWM, I would suggest Python, but we may go into it this series. It's going to take extra confusion and stuff. Let me turn up the quality here. There we go. That's better. Sorry about that blurriness. I'm going to turn up quality, but it slows the video recording down because this Raspberry Pi has a lot of load on it. You're also going to need to open up your Scratch. You're going to need to, we'll get into the programming part after. First, we're going to talk about breadboards so you understand them, because when you're working with wires and stuff, you don't want to have to twist them all together. You want a nice solderless breadboard. So we'll switch to the good camera and we're going to talk about it. The breadboard, I'm just going to turn the quality down so the lag goes down a little. We're going to switch to a camera and talk about the breadboard, okay? So I'll see you guys after we're done talking about breadboard. Hello guys, we're going to be looking at the breadboard, okay? So the breadboard is, let me get a screwdriver here so I can point stuff out easier. So the breadboard is basically for hooking up wires and stuff, because you don't want to have to try to, if I want to attach these 2 wires together, I don't want to try to go stick them together or twist them together and damage them and try to solder them together just to use them once. That would suck. Who wants, like, you don't want to try to twist your resistor and red light your freaking cord. You don't want to try to twist that. You want something that's not going to have to be soldered on or anything. So with this breadboard, you can just stick stuff into these little pinholes. But how do you know they're going to connect to each other? Like if I stick 2 items into it, how do I know this yellow and blue pin is going to connect? Or how do I know it's not going to be connected? Well, the way breadboards work is any pins in this row count as being connected, okay? But any pins horizontally, so vertically they're connected, and horizontally they're disconnected. So if I connect 2 pins here, if I connect 1 pin into here and 1 into here, does that look like they'd be connected? Kinda, but they're actually not, because they don't connect horizontally. They're all broken up in the middle. The only way you could connect these 2 pins is putting them in the same line. So now they're connected, okay? So anytime you put them in the same row this way, they're going to be connected. Looking at the positive and negative wire lines, that's what they're usually used for. That's why it's got a red ribbon and a purple or blue ribbon. These are actually the opposite. They connect horizontally, but they disconnect vertically. So they're not connected this way, they're connected this way. And this is in case you want to hook a positive and a negative up and have it string across the whole board, so you can pop little pins in anytime you want positive or negative. Okay. So that's the breadboard explained. And this smaller one is the same thing, only just like a middle chunk. It's not got those positive rails and negative rails. And a breadboard is always broken in the middle here as well. Okay, so none of these sides are connected. So they're connected up to here, and that's it. And then they're disconnected, and then they're connected up to here, and then they're disconnected. Okay, broken up here, here, and here. And then all these are connected like this. Okay, so that's the breadboard. I'm going to be using the smaller one for the first couple tutorials, which is the same. They're connected this way, but they're disconnected in the middle, and they're connected this way. I hope you guys can understand that. We're going to move back to the monitor now. Okay, so we just finished talking about the breadboard. Just gonna make sure it's recording there. So in this first episode, I'm going to be using the smaller one, only because it is unnecessary to have the great big breadboard out just for this little tiny LED. So we're just gonna use the smaller one in this tutorial, and you'll have one in your kit if you got the same kit. Has in the link in the description. If you get that kit, you'll be able to follow along with all tutorial series on this channel using GPIO pins or Arduino pins or anything. Okay, so I told you what you needed out of that kit. We're also going to talk about the GPIO pins on the Raspberry Pi so you understand them. They're basically general input-output pins. So an output of 3.3 volts or an input of 0 or an output of 3.3 volts and an output of 0 and an input of either or. 3.3 volts has 1 and 0 has 0. So that's 1s and 0s. And then PWM, it's only pulse width output, no pulse width input with the Raspberry Pi. Just so you know, it's 3.3 volt logic. If you're not understanding that, you don't need to. It just basically means it can only do up to 3.3 volt outputs on these GPIO pins. If you want to do any higher, you need resistors or stuff that can translate your voltage higher. And do not hook an Arduino directly up to your PI, because you could burn out your PI, because the Arduino is 5 volt logic. So, now that you know that, let's switch to the camera mode again and talk about the GPIO pins. And then we'll be back here and do the programming. Okay guys, so we're on the camera. Now I'm going to explain how your GPIO pins work. So a GPIO pin is a basic general input-output pin. Now what does general input-output mean? Well, it basically means it can output an input, or it's general input-output, so it can input or output 3.3 volts or 0 volts, okay? So 3.3 standing for 1 and 0 standing for 0. It can also input PWM inputs, and if I get my chart here, explain this in better detail if you look. So you have these 5 volts, those are just 5 volt outputs. If you don't understand voltage, you probably shouldn't be watching this tutorial. You want to learn voltages and amps and stuff first. GND is your ground, GPIO is your GPIO pin. All the GPIO pins are the same except these little blue ones, little yellow ones. They're capable of different things, like I believe these ones are I2C bus capabilities, have I2C bus capabilities, but we're not going to get into that because that's a whole other video, the I2C bus, which we will be doing with the Arduino if you get that kit in the description. 36, another thing you should keep in mind when you're putting GPIO pins into your program, use the GPIO pin number, not the pin number. This is the pin number. This is the GPIO pin number. There is a difference. 3.3 volt outputs, you have 2 of them. Same as the 5 volts, only less voltage. This is your average ground, GND, your average black wire. All the grounds are the same, no difference. The GPIO pins are your general input outputs, which are your signals. So you can send little 3.3 volt signals to anything you want, and then you can use that signal to turn on a relay or turn on a light and make robots move and stuff by sending out those little signals or inputting them. So that's how those work. And today we're just going to make a light blink, so we're going to send 0, 1, 0, 1, 0, 1 out GPIO pin 14 to make it blink. So that is how they work. I hope you can understand that. You have 27 GPIO pins on your Raspberry Pi and 40 pins in general, okay? So not all of them can do GPIO, like ground can't do GPIO. Only GPIO pins can do GPIO. You only have 27 that are GPIO capabilities, but they just call them general input-output pins because it's easier than calling them a great big name, okay? So, 5 volts. If you guys want to see this in more detail, go watch my first tutorial, or my Python tutorial, or I may just use this vid for both. I'm not sure yet. We'll see. So yeah, I hope you can understand that. And this is actually facing this way, so the 2 5 volts are actually in this corner, and the 3.3 is in this corner. So 2 5 volts, 3.3. You can find your pins using that, or you can get a ribbon cable, which I'll leave a link in the description, and attach it to your breadboard and attach it to your pins from that. I prefer not to, but you can get a ribbon cable, and I'll leave a link in the description to one. So yes, and then ground is all average 5 volts. There's no difference between the 5 volts. If you want to get 5 volts, you hook up to 5 volts in ground. If you want to get 3 volts, you hook up to 3 volts in ground. If you want a GPIO pin, they are 3.3 volt logic, so the Arduino is 5 volt logic, so you can't hook an Arduino and a Raspberry Pi up directly because they're different logics. You'll burn the Raspberry Pi out because the Arduino is 5 volt logic. I'm not going to get too far into that. If you don't understand what that means, just don't try hooking them up together without a proper converter. We'll get into that deeper later. But that's your general purpose pins. So these can send out zeros and ones, which is 0 or 3.3 volts, okay? And to blink an LED, we're going to send out 0, 1, 0, 1, and we're going to program it to do that using Scratch, which is really easy. So we're going to move back to the monitor now that I've explained that to you. Okay, we're back, guys. So we're going to go into the programming, and then we're going to hook up our LED, or should we? Actually, guys, we're going to hook up the LED first. That seems like a better idea. So, to make sure you have all your supplies and your 200 ohm resistor. We have the resistor so we don't burn the LED out, because if we send that full 3.3 volts to the LED, it'll burn it out. I hope you understand everything I'm talking about so far. If you don't, let me know in the comments, and I'll try to explain stuff better and more deeply next time. So you're going to need your breadboard. You can use the large breadboard if you'd like, and if you have the ribbon cord, you can hook that up to your large breadboard and use the pins on it because they're easier to see. If you need a ribbon cable, link in the description. And that should be everything covered. We are now going to hook up the LED. I'm going to show you how to do that. and then we'll go into the programming set. So let's switch back to the camera mode, hook up the LED, and then do the programming and get this blink going. Alright guys, we are now at the camera, ready to hook up the LED. So, keep in mind, when you are hooking up the LED, know that the positive is the longer pin, and the negative is the shorter pin on the LED. So see how this one's longer than this one? The longer one is the positive. Keep that in mind when you're hooking it up, so you know what side. So the GPIO pin always hooks up to the longer pin, and the ground always hooks up to the shorter pin, okay? Your resistors to slow down the power, because if you send all 3.3 GPIO pin power to this, it'll burn out. This guy, he's like, oh no, slow down power before it comes through. It doesn't matter what side you put this on, it could go into ground or positive to slow down power, but it does need to be put in, because if it slows down one part of the current, the whole current will slow down. So you're going to want to take your LED, stick it somewhere on your breadboard. I'm going to stick it to this side. And then you can see that my pins are like this, so I'm going to hook up, let's see what side is ground, the shorter pin is ground. Okay, so we want to use our ground, and I'm going to take the ground, I'm plugging it into the ground of the LED, and I'm going to take it, you can see they're in the same line, so they're connected. I'm going to take it and plug it into the side of the breadboard, so now ground is available over here from the LED. And then I'm going to connect the resistor to the positive side of the LED and bring it over to this side and connect it to this side of the breadboard. So now positive is here, ground is here. So I also want to connect positive to this yellow wire. So this is going to be our GPIO wire. And I'm going to connect ground here because we want this to be ground. So you can see everything's hooked up. I'm taking ground from this side of the LED, moving it over here, grabbing it again with this wire, and then I'm taking positive from this side of the LED with the resistor, bringing it over here, and grabbing it with this wire, okay? And the resistor is slowing down the power so we don't burn out the LED. So we're going to plug it in now. I'm going to be using GPIO pin 14. So you can see that GPIO pin 14 is right here. It's right beside ground, that's why I like using it, so we can see it's right beside ground and 3 pins from the end. So let's see, 1, 2, 3 from the end. So the pin is right here. See how it's 3, or I guess it's 4 from the end. And then we're going to hook up the ground, which is 3 from the end, because it's right beside it. Now we're hooked up to the positive to GPIO pin 14, and the negative to GND. So negative to ground, ground is GND, positive to the GPIO pin 14. The LED is now hooked up. This resistor is going to slow down the current so we won't burn it out. And everything should be hooked up correctly. Let me know if you understand this, and let me know if you had no trouble hooking it up. We're going to move back to the desktop now. Okay guys, we are back on the desktop now. Make sure you have your Scratch reopened. Now, when we're going into the programming part, see how Scratch is in these nice little bricks, so they're easy to grab. Whatever command you want to run, you just grab the brick you want to use and pop it in here. But we don't have any bricks for GPIO pins. I don't see any for GPIO pins. So how do we get around this? Well, we're going to use something that's known as a library to most programming languages. It's kind of like a library. We're going to go, it's actually an extension in Arduino. We have to add a GPIO extension. So we're going to go add extension. And then we're going to go and look for GPIO. Oh, look. If you guys have Raspberry in full, it'll be right here. We can find it right here. It says Raspberry PI GPIO. This is what we want. We're working with the GPIO pin, so we're going to grab it. So, now that we've got the GPIO, you can see it is giving us these 4 extra blocks. These blocks weren't here before. So now that we have these 4 new extra blocks, we can do lots of things with the GPIO pins. So these are all for the GPIO pins. See, when GPIO is high. The only one we're going to be using this tutorial, we won't be talking about many of these right now, but we're going to be using this one. So you're going to need to grab 2 of these blocks. So just grab 2 and drag them out, okay? So we're set GPIO this is where you put your pin number, so whatever GPIO pin you used, you put it here. And then to an output high, this is, do you want to put it to 3.3 volts or 0 volts? 3.3 volts or 0 volts? I want it to blink, so I want it to go to 3.3 volts, and then I want it to go to 0 volts, which is low. And what pin are we using? Well, I'm using pin 14. You put whatever pin you're using. I'm using GPIO pin 14. Remember the GPIO number, not the pin number. So I'm using GPIO 14. I'm going to put it in bold because I'm using it for the same GPIO pin. So it's going to set GPIO pin 14 to output high, which is 3.3 volts. Then it's going to set it to output low, which is 0 volts. So it's going to go on, off, on, off. But how do we start this program? We have no way of starting it. In order to start it, we need to go into control, events, and we need to pick an event so we have a way of starting this program. So I'm going to go when space key is pressed. So this is an event that will start the program. So you can put whatever key you want on your keyboard. I'm going to put enter, so I'm going to look for enter here. Or you can put it to any key on your keyboard. There's no enter. No, we'll leave it as space, okay? So when space key is pressed on our keyboard, it's going to run these two programs. Well, what's the problem here? We want it to blink forever. We want the LED to continue to blink till we want it to stop. In order to get it to blink forever, we can put it inside this. So now when space key is pressed, it's going to do this command forever, and then it's going to set this high, set it low, and repeat it forever using this loop. So that's what this guy does. Now, you think this would work, right? When I hit space key, it's going to blink it on, blink it off, and it's going to do it forever. Well, we have one more problem. We're telling it to turn on for 0 seconds, and we're telling it to turn off for 0 seconds. So that's not going to work. We need to put a time in. So we want it to turn on, wait 1 second. Then we want it to turn off and wait 1 second. So we're going to put a time in control. And you can change this time to whatever you want. If you want it to turn on for 2 seconds, you can put 2 in. If you want it to turn off for half a second, go 0.5, and it'll turn off for half a second. So now, when space key is pressed, it's going to repeat everything in this forever, and it's going to set GPIO pin 14 high. Let me see if I can drag this out now. Yeah, it's going to set, sorry guys, I'm trying to get it full. There we go. Set GPIO pin 4 high, then it's going to wait 2 seconds while it's on. Then it's going to turn it off, and it's going to wait 0.5 of a second. So it's going to go, when space key is pressed, do this forever, set it high for 2 seconds, then turn it off for 0.5 of a second, and it will repeat this forever. So, let me try hitting spacebar, let's see what happens. It turns on for 2 seconds, then turns off for half a second, just like we told it to. Let's change this to 1, and hit play. Or hit spacebar to get it to run this new program. Now it's turning on for 1 second and turning off for half a second. So as you guys can see, it's working great. What if we wanted to turn on for half a second and off for half a second? Now it's turning on for half a second and turning off for half a second. What if we wanted to turn off for 1 second and on for half a second? We hit spacebar. It's going to turn off for 1 second and turn on for half a second. So you guys can see how this works now. This is the GPIO blink using Scratch. This is kind of like your regular program. This is kind of like your Hello World in the robotics world using programming. So that is your first program written with Scratch and the GPIO pins, and you're only in your first lesson. So if you guys enjoyed this, leave a like, maybe think about subscribing. I want you guys to mess around with this and try some different times, and maybe try a couple different pins just to get used to it. Maybe try a couple more different things, like maybe make this one high and this one low. So I just want you guys to mess around with it and get comfortable with it. That's your homework. And yeah. I hope you guys enjoyed, and think about subscribing if you want to follow this series and enjoyed it. Thanks for watching, and have a great day.